Well, thank you so much, Rachel. And thank you for being here and already addressing us, First Lady McAuliffe. Thank you, Jenny and Nate, and all those who have put this amazing conference together. So, where we learn matters, and what we learn matters. And when I was 14, I had an incredible biology teacher at the Millbrook School who taught me the outline of life on Earth, which today we call biological diversity, before I was 15 years old. And this is actually a two-generation act today, because my daughter, Kata Petty, is here. Kata also went to the Millbrook School and is today a significant practitioner in green design with projects from the National Capital Area to Florida. So Kata, please stand up. So just a couple more prefatory remarks about, where we learn is important and what we learn is important. I firmly believe that we will never get where we need to get fast enough on the environmental and sustainability agenda until we are led by young people. And young people have incredibly important voices because nobody wants to seem stupid or bad in the eyes of their children. So feel empowered. You are the ones to lead us forward in what, in fact, could turn into the greatest environmental injustice issue of all time, not because it only affects the less advantaged today, but because climate change and all that goes with it will be affecting succeeding generations. So each and every one of you in this room should feel really emboldened with the leadership you've already provided and hopefully a great deal more. So what I want to talk to you about in a rapid gallop is the interaction between the natural world and climate change. We can sort of let it be personified by this peregrine falcon looking down on Central Park West at the climate march last September. But the interactions are important and profound. So in 1896, a famous Swedish scientist, Arrhenius, published a paper in which he was trying to answer, why is the Earth a habitable temperature for humans and other forms of life? Why isn't it too cold? And the answer was greenhouse gases at the natural concentration. What Arrhenius did not know was anything about the history of the climate of the planet in the last couple 100,000 years, or that, as you can see in the upper right, that the last 10,000 years have been a period of unusual stability in the Earth's climate. And that period includes all recorded history, an important part of unrecorded human history. It includes the origins of agriculture, the origin of human settlements. It basically makes the point that the entire human enterprise is based on the assumption of a stable climate. And then that same 10,000 years, all ecosystems have been adapting to a stable climate. And of course, that is now changing. So we're already seeing signals of that change in nature almost everywhere we look. Some of it is around physical aspects of nature. We are seeing lakes freeze up later in the autumn, the ice breaking up earlier in the spring. We are seeing glaciers in retreat all over the world. So Glacier National Park is well on its way to being that only in name. So in the tropics where there are glaciers, on top of very high mountains and volcanoes like Kilimanjaro. All tropical glaciers are retreating at a rate that they will be gone within 15 years. Sea level rise is now long beyond what's portrayed here. We have moved beyond a point where it's simply because of the thermal expansion of water responding to warmer temperatures. It's now also because of melt of ice on land, principally in Greenland at the moment. And so on the other side of Chesapeake Bay, the Blackwater National Wildlife Refuge, because of the combined subsidence of the land and sea level rise, is well on its way to becoming a marine refuge. And that same combination of factors applies to the coast right where we are in Virginia Beach. There's absolutely almost tight proof now that about more intense weather events, and particularly not more tropical cyclones, but more intense ones. And there's absolutely no question about the increase of frequency in wildfire in the American West. Milder winters, less snowpack, and we actually see it on our television screens in our media every year. The rest of what I'm going to talk about is biology. And so we're seeing plants and animals change their annual cycles. So at the Royal Botanic Garden at Kew, a whole series of plant species are blooming earlier every year. And it's not just plants that are changing their annual cycles, it's also animals that are changing. So in this particular case, tree swallows are migrating earlier, nesting earlier, laying eggs earlier. At least one species of hummingbird has ceased to migrate. And we're also seeing species change where they actually occur. So the Edith's checker spot, which is one of the two best known species of butterflies in North America, has clearly been moving northward and upward in altitude, trying to track its required conditions as a consequence of climate change in the American West. And the Joshua trees are literally moving out of Joshua Tree National Park. It's not that the individual trees are moving, but new trees are growing in places outside the park where they never have grown before. And the National Arbor Day Foundation, which I like to say is not some wild-eyed extremist environmental organization, but really just about people who love to plant trees, literally found it necessary to produce a new hardiness zone map to guide its devotees in choosing the proper species of trees to grow where they happen to live. The changes are not only on land, they're also in the oceans. So fish species distributions are changing, plankton distributions are changing. In the Chesapeake Bay, the eelgrass communities, which are incredibly productive, very important for blue crabs and other things, turns out that eelgrass is very temperature sensitive. It has an absolute upper limit beyond which it will not tolerate and be able to grow. And so the southern boundary of the eelgrass communities in the bay have been moving steadily northward year after year.